Well, first of all, thank you for attendance. And our today's lecture will be about the anomalous behavior detection. And first of all, let me introduce myself. I'm a senior lecturer here at BTH within PROMISE project. And I'm also an associate professor at Igor Sikorsky Kyiv Polytechnic Institute, Ukraine, at the Department of Cybersecurity. And also I'm a senior project manager at EBRD, which is a European Bank for Reconstruction and Development, and advisor to the Cybersecurity Department of the National Bank of Ukraine. And as for now, I have over 15 years in education. Experience started from 2005, I suppose, when I was on my master's program. And over 8 years, I am now in cybersecurity. In my fields of interest, you can see on the slide, it's data-driven security, anomaly detection, behavioral analysis, and machine learning. So our today's agenda is actually getting a little bit knowledge about what behavior analysis is and how do we define behavior, how do we define anomaly, and how do we detect anomalies in behavior, pattern-based or non-pattern-based. We will get a quick overview of tools and methods that are used and techniques that are used to detect anomalies in behavior. And in conclusion, I will give you some tricks, that will probably help you to get more out of anomaly detection. And at the end of this meeting, I will give you some presentation about our PROMISE project, about our courses that are ready now and being developed also, and how to apply for these courses. So basically, anomalous behavior detection. So we will now get through all each of these three words, and we'll figure out their meanings and how to actually understand them. So we'll start probably with the behavior, because anomaly is a kind of a characteristics of behavior. So we have to first define what behavior is. And when I was searching for definition of a behavior, something official, I found this one on a Cambridge dictionary. And behavior is the way that a person or animal behaves in a particular situation. And I was like, okay, so what does it mean, behave? And to behave is actually to show particular behavior. So I found that circle is closed and figured out that we have to find another source for inspiration. And behavior, according to Wikipedia, is the range of actions and mannerisms, right? And its definition is more or less explanatory of behavior, and it says that behavior is the range of actions and mannerisms made by individuals, organisms, systems, or artificial entities in conjunction with themselves or their environment, and which is now more specific, and we can extract some base points out of it. First, behavior is not a characteristics of human being only, or any other organic being. An artificial entity or even system of different levels of complexity can have a behavior. And here we must emphasize that this entity, or as we call it, acting agent, is put into the environment. And this means that behavior is a range of actions and reactions. So what the main features of behavior we need to know? First, behavior can be observed and measured. It's not necessarily equal. So being observed doesn't mean that it's being measured. But for purposes of our study, we count it as equal. Then it's changing over time. So behavior is definitely a dynamic characteristic of any system. And because any system has a multiple features that characterize its state, behavior may be represented as the vector of state and time. And these vector components can have numerical or categorical values, as they represent different subsystems, thus different data types. But these categorical values can find their representations as normalized numerical values. And later in this lecture, we'll give an understanding of how to transpose any categorical value to its numerical representation. And well, the simplest way to start learning behavioral analysis is the analysis of a time series of one dimension. But to actually perform behavior analysis, we have to always answer 6 main questions of what has happened, where, when, who is responsible for, and how this could happen. And well, from the perspective of behavior analysis, we don't really care much about the 5th W, which is for why. We don't take it simply because it doesn't help pretty much to understand the behavior. But in some very particular cases, knowing why helps answering other 5 questions. So we don't have to underestimate this question, and always keep it in mind. And keep these 6 questions in mind when choosing which data to analyze. And we'll get back to this a little bit later within this presentation. When talking about behavior analysis within cybersecurity domain, we should necessarily mention 2 subdomains here. A UBA, which is for user behavior analysis, and MBA, which is a network behavior analysis. And user behavior analysis is basically a permanent analysis of user behavior that is normally related to the user inside of some specific system, maybe operating system, CRM, maybe ERP system, or any specific application, etc. And usually, user is considered to be a human. In a broader meaning, a user is any acting agent, device, software, just anything creating an event, security events. And network behavior analysis, also known as behavior monitoring, is the collection and analysis of internal network data to identify malicious or unusual activity. And behavioral monitoring tools analyze information from a wide range of sources and use machine learning. And it's not necessarily, but still, sometimes it's used to identify patterns that could suggest an attack is taking place. Despite these sub-studies are different, I would count network behavior analysis as a part of UBA because, well, network traffic is normally generated by users or some devices which are still acting agents, and thus users, in a wide understanding. And now we'll try what anomalousness is. So we're proceeding to the first word in this name. So here is the very first definition of anomaly that I found in the Cambridge Dictionary. And take a look at that. Anomaly, a person or thing that is different from what is usual, or not in agreement with something else, and therefore not satisfactory. So it sounds like very fuzzy, right? So each person or thing, it's usual or not satisfactory, or maybe with something else. So we should find something more specific, more complete, because not necessarily something what is not usual, what is unusual. It's not necessarily an anomaly, because some behavior can be unusual but predictable and expected, and thus not anomaly. And when I found this on Wikipedia, it's just a page for anomaly. I was overwhelmed by the ridiculously huge amount of definitions of anomaly in dozens of domains and subdomains, and they're specified very, sorry about that, but specific. We don't need that precise explanation. And what we need is pretty simple explanation that at the same time can help us to understand how to detect this or that anomaly. And let's just use our common sense here. Every anomaly is definitely unexpected, because otherwise it will be an expected value. So if the actual value slightly differs from expected, it's no bad, we call it deviation. Let's say if expected temperature in the beginning of December, well, in Ukraine is around +2 Celsius, then 3 or 5 Celsius would be normal and wouldn't cause any anomaly alert. Another thing is when the temperature goes up to plus 20 Celsius. So we can see when the deviation becomes significantly bigger, then we call it anomaly. And now we can define an anomaly as a significant deviation from expected value. And the main issue now is how big this deviation should be to define the value as anomaly. What is this threshold? And this is a good question. There are some techniques. We'll consider them in a few minutes, again, within this lecture. And there's one more issue left, but it's very important. Take a look at this guy. He seems to be normally doing, right? So he's just sliding from the mountain down on the skis, right? But let's make some changes. Let's make it. And here it is. Now, it doesn't look normal, right? Agree? And how do you think, what do you think this is all about? What am I talking about now? If it's possible, please please mention it in a chat. I'm just going to give you a few more seconds, because it's really interesting issue, and people normally just skip it in their minds and don't understand that these actually matters. Okay, no ideas. Yes, exactly. Thank you so much. Cool. That's cool. Really, I'm talking about context, and always keep in mind the context rules, and the same behavior in a completely or even slightly different context may cause anomaly likelihood increase or anomalous probability increase. So let's now get to the detection issue. So the last word we have in this definition. So how do we define detection in this context? We know that behavior is a time series of vector of state, which consists of several dimensions characterizing system's component state. In case of endpoint protection, well, just for instance, the endpoint state could be represented by CPU usage percentage, CPU temperature, SSD response time, bytes read, bytes written, etc., etc. So we know that also the anomaly is a behavior that is not expected. So basically, anomaly detection is a consistent, permanent, real-time monitoring of these states to find deviations from expected. So this is how simple on the one hand it is. Well, just a spoiler, on the other hand, it's not. And why do we talk about consistency and real-time monitoring? Here's an example of the main attack stages. It has three main phases: preparation, execution, and covering up the tracks. And normally, these actions are being a subject of forensic afterwards, after the attack has happened. But if the attacker is mature enough, we might never find any evidence of his presence. So when we talk about anomaly detection, we assume that we're dealing in a real-time or near real-time regime to detect and then maybe prevent or counteract the attack, or at least minimize its impact if it had already happened, or at least collect some more evidences, digital evidences for the future forensic process. On each stage of attack, there are multiple indicators that represent this or that attack. For a well-known cyber kill chain, for every single stage starting from reconnaissance, we may face a lot of abnormalities, like abnormal DNS reverse lookup requests, anomalous amount of failed authentication requests, which may be an evidence of a password guessing or a brute force attack. It can be unusual activity from blacklisted geolocations, or maybe failed privilege escalation, or not failed. Maybe there was some activity from for a long period of time not active service inside of our security perimeter, or an unusual number of messages to the system to bypass the forensic, etc., etc. All these activities might have shown us a possible, and I emphasize possible, intrusion or any other kind of attack. Why just possible and not actual? Because we consider the worst but deal with the fact. And these activities may be absolutely legitimate despite their abnormal nature. And keep in mind that the anomaly detection is just the preliminary stage for response, and the response has to be adequate to the activity. Well, let's say what I mean is you forgot the password and trying to remind it, right? So you've tried several times and failed for some reason. You're legitimate and you're blaming yourself. You may want to renew it, or in the worst case, get an old one to your email. But you definitely may not want your account to be suspended, right, in an automatical regime, especially if you are an admin or any kind of privileged user. And there are some kind of attacks that are, that look like this. So basically, what kind of anomalies we're looking for? There are three main anomaly types. One is point anomaly, also known as outlier. Another one is contextual anomaly and collective anomaly. And what are the differences? You can see it out from the slide. But let me explain. Point anomaly is normally a global outlier, having a significant statistical deviation from some mean values in a specific time frame or the whole time series. Contextual anomaly is normally represented by some local outliers, right? They're not changing the statistical characteristics significantly, and they normally lay inside of the normal distribution. So they cannot be detected by standard statistics methods. And collective anomaly is the type of unexpected behavior when statistical characteristics are changed in a certain time range and then go back to predictable behavior. So as you can see on the slide, right? So it is within the normal distribution, and it's within the mean values, but still it's an anomaly because it's unexpected and it has changed some statistical parameters. And also there are two types of anomaly detection from its time relation perspective. Normally, we may talk about static anomaly as a parametric outlier, a point in multidimensional space that lays very far from the main kernel point. And static anomaly is different from dynamic one because it remains to be anomaly over time. Instead, dynamic anomaly is based on a strictly relation, is based on and related to time. Dynamic anomaly may also be transposed to static in terms of distribution density and some other statistic parameters, and only for anomaly of outliers. And now, a few words about mentioned supervisor anomaly detection and unsupervised. In other words, anomaly detection based on patterns of behavior and patternless anomaly detection. Or sometimes it's called signatureless. To train anomaly detection system to recognize very specific behavior patterns, we must show system the training examples of what is right and, which is more important, what is wrong. Then, based on these examples, system will get trained to recognize new input. And not to mention that we don't necessarily have ability to perform this labeling, especially if we deal with a new or more complex data or more complex type of data. Or when we don't know whether we have anomaly or not. So the system is observable but not measurable. And also depends on domain and thus context. And now here's an example of a log entry. It's taken from the web server access log. This is just a piece of data that can be gathered, so it's not complete. You may find much more information to be collected in the specifications of the NCSA common log format. Technically, this information is not even a security information, but it can be used for security reasons. And frankly speaking, you can convert almost any information to a security related. Remember that 5 W's plus H, so six questions. So if you don't know what to start from, just start answering these 6 questions to obtain the security related information from your system. And now I'm going to give you a trick of how to extract security-related information from the raw non-security-related data. And here's the trick. Normalization is the answer. You can normalize whatever you think is relevant to whatever you think is possible to normalize to. Let me explain. I'll give you an example. The given information on the request IP is useless in time series simply because if you categorize it, let's say replace IP address 0000 with just 0, 001 with 1, and 002 with 2, and so on, so on. You'll just get a huge number of categories that don't give you any statistics. They're all different. And well, when talking about decision making or clustering, it may be helpful since your supervised learning can train systems to recognize specific IP addresses or pools. But how to get the behavioral statistics? Let's find an average amount of requests from this IP in a specific time frame. And now we can have a great evidence of how categorical data is converted to numerical and can really help and can create a time series. And same here with the average amount of requests from particular user. It can also become a dimension. Then converting strings into numerical values can be performed as, well, let's say a string length, right? So it's a numerical value. The parameters count. So if we have some HTTP refer or HTTP request, we can have some parameters in the string. So count them, and you will get a new numeric value. Well, it may be entries count of specific symbols in a string, and some kind of that information. The only initial numerical value in our example is actually a byte send, and it can be used as it is. So you can take it into consideration when performing an anomaly detection, but don't be afraid to use a normalized values, even it's already numerical. You can add in extra features by normalizing, by reducing these numbers, and normalize it. Let's say to request per time or byte send per time, per minute, per hour, per second, whatever. And just keep in mind, normalization is normal. It's your new slogan for data-driven security. But please know some dimensions may be correlated. So you have to also perform the correlation analysis before adding any feature or introducing any dimension. Now let's take a look into possible ways and techniques to detect anomalies. It's not the complete list of approaches applied to anomaly detection problem, but it shows some specific. Okay, first, there is a problem of the outliers detection, right? And this is probably the most studied and well-known field. And it now includes all known methods for detection, including statistical methods that are based on the normal distribution and deviation from it. And statistical methods have their pros and cons. And well, it's true, it's quite fast and simple. So statistically, you can analyze any time series, and it's like this fast and pretty simple. But there are some cons. Statistical methods allow outliers detection on a static time series, and well, it allows to deal in the real time, but it's a little bit trickier for real-time outlier detection. It doesn't allow finding context anomalies and collective anomalies for the same one reason, since the context and collective anomalies, they're hidden inside of a normal distribution, except when using sliding window, but it's another issue. Then machine learning. Well, machine learning is now one of the most talked about, right? So it can be supervised and unsupervised, or I didn't mention that before, semi-supervised, which means that supervised, that we show when training, we show to our system both positive and negative outputs. In unsupervised, we show nothing, and on semi-supervised, we, let's say, show only one part, like just one type of cluster, one type of class, like negative, right? So everything that is not negative, the system is learned to be to recognize as positive. So it can also be used for any type of anomaly detection. And now we have a lot of techniques. It's not a subject of today's seminar, but we have a lot of techniques to actually recognize anomalies of different types, but they're all based mostly on a pattern recognition. But there are some cons. It fits the best to the data that has been given preliminary. So first of all, you have to have this data preliminary. You have to have a deep understanding of this data and its nature, and the understanding of what is normal, what is not. So it involves more, more people, more thinking, and it needs labeling. And it also doesn't learn while working. And well, there are some exceptions. There's kind of a new approach of adaptive machine learning, but again, it's not a subject here. To feed more data types and scales, and this model should be given some specific patterns. Like I mentioned, you have to have all these patterns, and you have to know your data very well. And artificial neural networks. Well, this is one of the best, right? So, and one of the best of it is that it's super accurate and precise. We now know that neural networks, they have a precision over 98%, which is great. And also, neural networks can process a large amount of data with lots of features. In case if machine learning doesn't perform well in a huge amount of features, right? But it also has probably the same cons. Again, it takes a lot of time to train the model and requires quite deep understanding of the nature of your data. It also requires, again, data pre-processing. So you'll probably need to label this data, so to give an understanding to when training the neural network. You will have to give an examples of what is good, what is not good. And it is data scale dependent, or again requires additional normalization while working, because we can have an absolutely new type of data, new scale, and this will always be counting as okay, it's anomaly, but it's not, because we have made some kind of a shift to a new state of our system. And well, there are some combined methods that combine different techniques and approaches in a multi-step anomaly detection. And finally, you can mention that I have highlighted the prediction-based models. It's not actually a methods or a set of methods. It's the common approach of anomaly detection. So it's mostly applied exactly in a time series analysis. And there are some the main approach, the main idea of this approach is basically to predict the next step, which means remember we were talking about the behavior should be expected, right? And even if it's not expected, unexpected, so then it's anomalous. And the prediction based models, they're based on a prediction function. So we predict the next step, or maybe next few steps of our time series, and then we compare it to the actual values, and we measure this error, and they also are normally called error based. So they use as a prediction function. They use autoregressions or moving average, or maybe combinations of them, autoregressive moving average, or maybe autoregressive moving average with a seasonal component, which is a SARIMA model, and all this. You can find lots of them on the internet. So, but there are some smart guys who has already implemented all these techniques, well, most of them, and methods to achieve the goal, which is anomaly detection. And they have created tools for easy to use anomaly detection in time series. for both security-related and non-security-related issues. And I'll tell you more non-security-related issues were the first, the initial ones. And now, how do we define the best anomaly detection system in case if we are required to stick to one of those? And there are 4 essential features for anomaly detection system. You can see them. Anomaly detection is the most important feature of anomaly detection software. Well, because the primary purpose of the software is actually to detect anomalies. And the software allows security users to spot any unusual patterns, behaviors, or events. It can detect and monitor recurrent events, trends, and correlations by deriving patterns from metrics. But the anomaly detection feature would be a useless feature without the mechanisms for alerting users when the system detects an anomaly, right? Anomaly software notifies users in real time by sending alerts, and by alert we mean, well, it can be any road, text message, email, or it's very popular now to integrate some third-party applications. And this feature allows the system administrator or any user to react to create critical alerts and train the system to stop sending alerts in case of a false positive. And I would also add that in case of ability of the system to learn from user. It's another feature, but it's not crucial. Then anomaly detection software includes configurable dashboards that enable users to display metrics in different ways. And security specialists can use dashboards to visualize their data in real time. For example, users can use a web browser to view the most important metrics in charts, lines, bars. And this actually helps to make decisions, especially in the security domain when decisions are very important. And the best anomaly detection software now can easily integrate with the existing systems. As I mentioned, third-party components, and we can also sometimes integrate common programming languages such as JavaScript, Java, PHP, Python, C#, whatever. And you may agree or disagree to this list, as you can see on the slide. Still, just an example, and some main ads are included, and it hasn't been done from the perspective of cybersecurity. So just to kindly mention, on the slide you can see the words highlighted with the green color, and these are cybersecurity related. They're made specifically for cybersecurity reasons. So one of the most favorite, my personal top one, is a Splunk Enterprise. And next, top 2 is Elastic. It's more tricky to to get ready to do the work, because it's quite it's quite challenging to make your first import of the data, and then you're good to go. You can do whatever you want. And also, please mention this Sentinel-1 and Darktrace. So basically, what are the differences between these lists? The top, how many? 6, 7 applications. They're actually made as Splunk is actually a CEM, Security Information and Event Management, and all of the rest. They're just an applications for anomaly detection. So no matter, it's not security related, like I mentioned. And down here, Sentinel-1 and Darktrace, as you can see, these are specifically IDS, so intrusion detection system. And they are learned to be intrusion detection. So they're learned not only detect an anomaly, they're also learned to counteract it. Well, and at the almost very end of my speech, let's make some conclusions and emphasize some tricks. Well, behavior is as we mentioned, is actions and reactions, and that we can measure and also expect, right? So behavior can be expected. Behavior is always put into the context. Again, it's very, you have seen the picture with the ski guy. So context matters. Anomaly is the behavior that we do not expect. Anomaly can be found by patterns or behavior expectations or patternless. And which is more important, anomaly may exist even you're not aware of it. So you can think that your system is up to date, it's normal, but it's not. So keep watching and like we mentioned already, extend your monitoring area. So normalization is normal. Here's the trick. When you build up your anomaly detection system, keep collecting as much information as you can. There's no overload nowadays. All these systems that we mentioned can chew and swallow, terabytes of information like this, and thus this gives you more opportunities to have more complete understanding of your system, of your system's behavior, both inside or maybe on the perimeter, or even sometimes outside. Being a little bit paranoid and collecting data is okay, trust me. Measuring the temperature of your teapot may once help you to detect a data leak from one of your office workers in the midnight. So don't be afraid to be normally paranoid. And just to mention here, it's not an advertising. I also work on a prediction-based patternless anomaly detection. And well, now we have some practical results allowing to detect anomalies on the fly in real time with no machine learning, no trainings, teachings to complex neural networks. And this system is enabled to work on a different data scale, and it's adaptive to time series changes. So drop me a message if you're interested in cooperation or you know someone who is.